Okay, let's get this show on the road. Hello, everyone. Hope you're well. Welcome to another edition of Math 1000. Hope you guys had a good week. Today we have a Q&A session because we have a quiz on Monday. So I just want to make sure we go over that. Let's actually just jump right in here. Looks like most people are here. Maybe we're missing one or two people. So let me share my screen here. Okay. And there we go. So you should be able to see the full screen at this point. Okay, awesome. Let me make sure I'm seeing the chat as well. Let's set this stuff up here. So hopefully you guys are good. So let's start off with some PSAs, public service announcements. So remember, we do have a quiz next week on the 28th. So that is on Monday. So Monday's class is a quiz. It covers lectures 4 through 7 on the pre-recorded lectures. And the essential topics for the quiz are exponentials and radicals, simplifying and rewriting expressions like combining terms, expanding parentheses, things of that sort you should know how to do. Special products and special factoring, so like applying difference of squares, sums or difference of cubes, etc. Factoring in general. So knowing about all the techniques that we learned about factoring out GCFs, factoring by grouping, factoring trinomials, the AC method, etc. Knowing when to do which, kind of the general strategy behind factoring. I also spoke about that in class, as well as equations. So I didn't do a lot about equations in those lectures. I believe equations we deal with more in depth in lecture 9, if I'm remembering correctly. However, I do introduce the concept of an equation, and I do mention some things that you can do when an equation is present, as opposed to you can't do them when an equation is not present. So for example, you can't just randomly square something if there's no equal sign, right? If you have an equal sign, it is valid for you to square both sides of that equal sign, okay, and that's okay. Or you can divide both sides by a non-zero number, or there are all these things that you can do when there's an equal sign there that you can't just do when there's not an equal sign. So if I give you an expression, there's no equal sign anywhere, and it has a radical, you can't just randomly square the radical. So things that I touched on things like that, but I didn't go too in depth into equations, but basically know what they are. Yeah, so those were the topics that were covered, and we extensively went through these topics. I gave you all kinds of tips and strategies, and talked about the nuances and all that stuff. But these are basically the things that you need to know for the quiz on Monday. That being said, I did get an email from someone that I didn't respond to yet. I will, but apparently Monday is also a Jewish holiday, from what I remember. Okay, so essentially, I'm going to respond to this personally, but I just don't want anyone to feel like I forgot about them because I didn't reply to the email yet. So essentially what I would think in that situation, if you have to miss Monday's quiz for religious reasons, I think the best day to make that up would actually be on the Sunday. But we'll talk about that afterwards, because I make the answers available right after the quiz on Monday. So taking it after that is kind of no bueno. Okay, so that being said, those are the topics. So that's what you need to make sure that you know. That's what was covered in lectures 4 through 7. And of course, anything that I previously covered that incidentally you would have to know, then yes, right? So a lot of these things will involve you knowing about things that we spoke about previously, but this is going to be the focus of the quiz. So these are the things that you should know. So I'm going to provide the notes to this lecture as well, of course, but you can like take a snapshot of this so that you kind of know in your head what you should be prepared for. That being said, let's move down. So one thing I did want to talk about is there was another student who emailed me, and I don't remember who this was as either, because this was a week or two ago, but they mentioned to me an additional technique that they learned about factoring in high school, which was called the payback method. Now, personally, I never learned this when I was a little Jhevon, and the student couldn't actually explain what they did. They just knew how to do it. So I looked it up and I'm like, okay, it's all right. And so I decided that I'm just going to tell you guys about it as well. So this is a method that would be used in place of the AC method. This is a method that would be used in place of the AC method, and you don't have to learn it. You don't have to do it. You can literally just ignore this section of the lecture if you're happy with your factoring skills. But I thought I'd just mention it just because this student mentioned that they use it, and I found a website right here that I think explains it. They didn't do a lot of examples. They probably do one or two, but I think it explains it reasonably well for anyone who's interested in learning another technique. Maybe you didn't like either the AC method, nor you weren't really a fan of the trial and error method. This is another method for you. So before we get into the Q&A section of this class, I figured I would actually just show you how this method works. As for why it works, I'm not going to take the time to explain it because as far as I'm concerned, this is optional knowledge. So I'm not going to go into depth with it, but I just figured I might show you guys how this thing works. So these were some examples that we did in class. I'm going to redo them using what's called the payback method. And just so you can see, you have another tool in your arsenal. But like I said, it's an optional tool. You don't have to know this. But I figured it's cool. It's a new technique, and let's make things interesting and let's actually talk about it. So here is how the payback method works. That's the word P. Payback method. I think this is on an unstable surface or something. Okay, so the first thing is you kind of do the AC method. So step one would be to remove leading coefficient and multiply it by C. So that is, you're going to start with this okay. So it's kind of like you're creating the AC again. However, now you just assume it's a monic polynomial, right? So you just remove the coefficient, multiply it by the last guy. Now the second thing you want to do is factor this new one. So in this situation, because the coefficient of the squared term is 1, you can just think of two numbers that when you multiply, you get the last number. When you add them, you get the middle number. Those numbers here are 4 and 1. However, because the coefficient was not 1, what you now do is you replace the x with the original leading term. This is what's called the payback. Right, so you took away the 2 in the beginning and just literally took it away. So now what you want to do is you want to pay it back. Right? I think that's where the name comes from. And so I don't want to write equals here because technically it's not equals. Let's do that weird arrow. So this means instead of x, you're going to rewrite 2x. You're going to put back that coefficient that you took away. What you're going to realize is that one of these guys will factor, or one or both of these guys would factor further. So notice that in the first term, 2 is a common term. You can factor that out. And so now the last thing to finish off is you divide by the original leading term. In this case, 2. So essentially what you do is you just divide this answer by 2, and you end up with this guy, x plus 2 times 2x plus 1, and that's going to be your answer. Right, so this is called the payback method. Okay. So here I wrote out the steps. Let's actually, let me run through another example, so you can see it without me writing down the steps to get the flow down a little better. Okay. And then maybe you can ask me questions if you want. Okay, so suppose we have this. The leading coefficient is not 1, so this would call for the AC method, but let's say you don't like the AC method and the trial and error method confuses you. Here's another option. What you can do, and I'm writing arrows here because it's not right to say equals because technically it's not equal or anything like that, but it's also not right to write the implication unless you know what's behind it. So I'm just using this word notation here. So what we would use is the x squared plus x. We'd multiply the 6 and the minus 2. Then we'd factor that. So minus 12, you need like a plus 4 and a minus 3. Then we'd put back the 6. So this is the payback. You will notice that in the first term, 2 is a common term. And in the last term, 3 is a common term. So this gives you 6 times 3x plus 2 times 2x minus 1. And then you divide by the original 6. So finally, you're left with 3x plus 2 times 2x minus 1. And that's your answer. I do want you to note we use this instead of equals or implies. So in class, when I was going through the other factoring methods, I use, okay, this line is equal to that line, which is equal to that line, because that was in fact true. In this case, it's not true. This quadratic is not the same as that quadratic. So these two are not equal to each other, right? But it's just there's a reasoning behind this. There's something going on behind the scenes of why this would work. If you want to know specifically what that thing is, I think this website actually explains it pretty nicely, but I don't want to actually waste time going through that. So that is what a full going through this problem fully would look like. Okay, so it's like you remove the original leading coefficient, multiply it by the constant term, you'll get a monic polynomial, which you can factor using the easy method of factoring quadratics. Put back the leading term, factor out any common terms that remain. Then what you're going to do is you're going to divide by the original leading term, which in this case was 6, and then what's left over is going to be your answer, right? So this is called the payback method. So it's kind of, it's just a modification of the AC method that gets back to work. And I think that is correct. Yeah. So now what's really happening here is that the x that shows up in this line and that line isn't really an x. It's a new variable that's equal to 6x. But I don't really want you guys to worry about that right now. So that's the payback method. Just wanted to show you another option. Did anyone else learn this method in school? Is this new to everyone, or, oh, the comments I already just made. Did anyone ever see something like this before?
I haven't.
No?
I learned it, but I didn't know it was called the
Payback Method.
Okay. So it's just another option. Yeah, I never heard about it until someone mentioned it to me like a couple weeks ago. I was pretty happy with the trial and error method. So yeah, but it's just another option. In general, I don't force you guys to do things the way that I do them, but whatever way you're doing, it should be some valid mathematical way of doing stuff. So you can use your own ways of doing things if you want. I wouldn't downgrade you for that, just as long as it's valid. So it's not like, oh, I do this and then magic happens and this happens. No, you should be able to explain what you're doing, be able to go through a logical process. It needs to be repeatable and logical. And so there is a logic to this, but a lot of it is behind the scenes. And it comes down to actually multiplying by the leading coefficient, rewriting the expression, and that's why you have to divide by the leading coefficient in the end, because you actually made that change in the beginning. But when you write it out in the way that I'm doing here, you don't really see that step happening. So yeah, that's called the payback method. Let's run through it a couple more times, right? And again, completely optional. If you don't want to do this, you don't have to learn it. It's just another option that's out there, so I thought I'd share it. Okay, so let's say we had this one, 5x squared minus 14x minus 3. So what we would do is move the 5, multiply the 3, so I get 15. Then I'm going to factor this new guy. I could actually use an equal in this line, but whatever. 15 and 1 seems to work. Make it a minus 15 plus 1. Then I'm going to put back that 5 that I had to remove. I have to pay it back. Now, there's a common 5 in the first set of parentheses. And now I divide that extra 5 out. Okay. So the nice thing about this is it's what I like about it, it's very self-contained. It's not like the AC method where you have to go separately and do the AC and figure out the product and then the sum and then come back and plug it in and then do the factor by grouping. You can actually do everything in just one line in one sequence of steps here without needing any side steps. So that would be the benefit. The thing that I don't like about this method is that I don't want students to think that these lines are equivalent, because my second line here, this line that I wrote down, is not equivalent to the first line. It's a whole other quadratic that I'm using out how to factor some other quadratic to help me figure out factoring the original quadratic. So there's a loss of equality here. It's actually a whole separate process, and I just want you to be aware of that. But that is the payback method. If anyone would like to take a crack at that method with this last example, and then we'll start the Q&A. I'm all for it. Let's actually get some space here. Okay, so this was also an example that we did in class, but maybe anyone wants to tell me how to do this with the thing that we just learned, if you're comfortable. If you kind of like it and you want to make sure that you understand the steps and you won't forget anything, maybe now's the time to actually see if you can actually do it. So any attempts? Anyone wants to attempt it? I mean, what would the first line look like? I mean, I can scroll back up here or something. So you guys can take a snapshot of that. And then I'll scroll down. And you guys can try that. Okay. Okay. So what would the first line look like?
X squared plus 17x plus 72.
Okay, then
In parentheses, x plus 8. And then in another parentheses, x plus 9.
okay, then what do you do?
You bring back the 12 to make it 12x plus 8, and then 12x plus 9.
Right. And I assume this is the step that's called payback. I'm guessing that's where the name comes from. I don't actually know for sure. Then,
Can't you factor out of 4 out of the first set of parentheses?
okay,
And then you leave the second pair alone?
no, the second pair also has a common factor.
3.
So now you can take the 4 times the 3, that's 12. Okay, now what do we do in the last step?
You divide by the 12.
Right. Yeah, that's going to be your answer. So that is called the payback method. Just another option for you guys out there, for anyone who is interested. If you're happy with the way you've always done it, you can always do it that way. There's no reason why you have to learn it this way. It's just another option. It is something that you can use in lieu of the AC method, if the AC method isn't your jam, or you also don't like that other one. Okay, yeah. So I thought I'd mention that because someone brought it up. And I also just wanted to mention that in general, as long as you have a valid mathematical way of doing things, you can explain it correctly. Whenever I ask you to show your work, you can show your work, it's repeatable, it makes sense moving from one step to the other, then I am all for it. Okay, so now that being said, let's go into the Q&A portion of the class. So here's where you're gonna ask me questions about, you've gone through the lectures. At this point, you should have watched up to lecture 7, which is what the quiz is going to be up to. So anything you want to ask me about that, now is the time. And just to remind you, these are the topics that were covered. So if there's anything that you found confusing when going over the lectures on these topics, now is the time to get that confusion cleared up so that on Monday at the beginning of class, 11:30 a.m., you'll be ready to take a quiz. And again, the quiz is on Gradescope. On Gradescope. At start of class. Okay, so questions, comments, concerns, anything that you want to make sure
I have 2 questions.
Yeah, sure. Charlotte.
Okay, my first one is about the quiz, and then the second one is a problem.
Okay.
Is the quiz going to be the same format as last one, like 30 multiple choice questions, 30 minutes?
Quiz format. Yeah, essentially the same. I don't know how many problems you'll see, but it's going to be the same multiple choice. You have a timer. And it's going to be around 30 minutes, yeah.
All right. And then my problem that I had a question about is actually one that you did in the video, but I was just having trouble like following along and like understanding exactly like why each step happened.
Okay, what problem was that?
It is x to the 6th power minus y to the 6th power.
Okay, and we wanted to factor.
Yeah.
That was the problem. Okay. Do you remember what we did in class when we wanted to factor this?
I know like we did like x squared to the 3rd power minus y squared to the 3rd power.
Mm-hmm.
But like again, like
But we
I was
commented that that didn't work as well as the other way.
yeah, like that was like I was like confused like about that. Like that's the part that was throwing me off.
Yeah, because when you do it that way, it's hard to see that things would factor further than had you done the other way. So yeah, so one thing you will notice, and this is based on the strategy, there are two ways to think about this. So there was a general factoring strategy. It says, okay, you have this random thing that you want to factor. These are the steps that you should go through to try to factor. The first thing was to look for a GCF, a general common factor, and factor that out. The second thing was if it has two terms, think of the special factoring formulas like difference of squares, difference of cubes, sum of cubes, right? So this strategy here that's where you would think. There is no common factor. There are two terms. Because there's a minus sign, there are two things that should come to mind immediately when I look at this. One of these is difference of squares. And if I'm looking at it as a difference of squares, I want to write it as something squared minus something squared. And then because of the laws of exponents, I know that x to the 6 I can think of as x cubed squared and y cubed squared. So that's one way I could look at this thing. The other way I could look at it was as the difference of cubes, which means I want to think of it as something cubed minus something cubed. Someone trickling in here, right? And so because I know laws of exponents, this would be x squared cubed and y squared cubed. So I have two options of how to think about this problem. And the question was, which one was better? Which one would get me to a nicer answer? And what I discussed in class was this is the better way.
Would you like have to do one
And
problem now?
And let me just finish saying something here. And this you can think of as a general way that you want to approach not only these problems, but math problems in general. If you have two strategies that could work on some problem that you're thinking of, it is almost always better to go with the easier strategy, the one that's at the lower level, the one that's easier to apply, etc. So when you look at the difference of squares formula versus the difference of cubes formula, the difference of squares formula is a lot simpler, it's a lot shorter, it's a lower level, right? Difference of cubes formula gets longer, and you can have formulas going all the way up. So you have difference of fourths, difference of fifths, difference of six, etc. Right? So there's actually a formula for the difference of 6 powers, but I didn't really tell you guys about that. But it keeps going up. So the difference of squares is almost on the ground floor, right? So that is the simpler technique. It is almost always better to apply the simpler techniques before you apply the more complicated techniques. So that being said, here's how we would go about it. And after I finish, you can chime in here. So you would apply the difference of squares, which tells you that it's one thing minus the other thing times one thing plus the other thing. And here you'll see that now difference of cubes and sum of cubes apply. So the difference of cubes would apply to the first parentheses, the sum of cubes would apply to the second parentheses, and you can break that down further. So that's going to be x minus y times x squared plus xy plus y squared. And then this one will be x plus y times x squared minus xy plus y squared. And so that was the answer. Okay. So that is cannot be factored any further. Conversely, if we thought of it as the difference of cubes, you would get something like this. You would end up with x squared minus y squared. Then you'd square the first thing plus the product of those two things plus the square of the last thing. And so what you'd realize is that it turns out that, let me move down to the next line. The first is a difference of squares. So you can definitely break that down. But the thing is, when you look at this guy, this factors further. But it is not obvious. How? Right? Now, I do teach you a way to figure out when a more obvious way to know that that would factor further. But at this point, you don't really have a technique that would tell you how to factor that further. And even when I teach you that new technique, it's still not going to be super obvious that this thing factors further. You'd have to do a lot of trial and error to actually figure out that x to the fourth plus x squared plus y to the fourth actually factors further. Even if you think of this as a quadratic, it would kind of be equivalent to the quadratic that says something like x squared plus x plus 1. That's something that it would be considered equivalent to, but x squared plus x plus 1 does not factor based on what we've done before. So it's actually not obvious that this would factor. So the student who runs into the difference of cubes first, they would actually hit a roadblock that the student who tried the difference of squares first would not have ended up in. And so that was the comment that I was making in the class. And that was just, it's a general principle that works out well most of the time. If you have a couple different strategies that can apply to the same problem, I don't want to say always, but almost always, every situation that I can think of, maybe there's some obscure situation out there for which this isn't true, but every situation that I could think of off the top of my head, it's better to apply the simpler strategy before applying the more complicated strategy. I actually had this issue in my calculus class this semester as well, where I gave them a problem where they had to solve it using a calculus method. However, it was possible to simplify that problem using algebra before applying the calculus. And it turns out that the students who directly tried to apply the calculus, the problem became so complicated that they ended up getting the question wrong. However, the students that first simplified it with algebra and then applied the calculus, the answer was so easy, it was a joke. And so it was like, because they hit it with the calculus methods before hitting it with the algebra methods, they ended up in more trouble than had they hit it with the algebra method first and then hit it with the calculus method. So this example, that was basically what I was trying to show you. Whenever you have several strategies that can work on the same problem, it's almost always better to apply the simpler, lower level strategy first. Because when you apply a more complicated strategy, you can get in trouble. You can get in a situation that is more complicated to deal with than normal, okay? So that's what I wanted to emphasize with this example here. So that's kind of the summary. Now, that being said, do you have any comments at this point based on all of that?
That was really helpful, like the splitting and like the breakdown.
Yeah, so when you see it side by side, I think it's more clear. I think in the lectures, I had to erase one before you could see before I had the board space to write on the other one.
Yeah.
But yeah,
It's,
side by side, when you do it side by side, you'll see that on the left, in the left column, you definitely could get a lot farther and factor things further than with the right column. Jumping into difference of cubes, it factors obviously into 3 factors, but clearly by using difference of squares, I can get it down to up to 4 factors. So clearly it's true that the x to the 4th plus x squared plus y to the 4th actually factors into x squared plus xy plus y squared times x squared minus xy plus y squared. But it's not obvious that that would happen. At least it's not obvious with any of the techniques that you would have learned up to this point. And so that was the main idea behind that example. And not only does it work for things like these, but like I said, in general, take this as a general across the board kind of thing. If you have a couple strategies that can apply to the same problem, apply the easier one first. You'll almost always end up in a better position. So yes, so you do need to actually know the strategies. You should know and be very good at both of them, difference of squares and sum and difference of cubes. However, if you're in a situation where both of these apply the difference of squares first. Yeah. So hopefully that's more clear now. And I kind of, maybe I should minimize this a little bit so you can see the whole thing. So hopefully that is a little bit clearer. Unless, do you have any follow-up questions? Did I fully answer your question?
yes, that was perfect. Thank you.
Okay. All right. Any other questions from what happened in the lecture or what you were practicing on homework or anything? I believe our class ends at 12:45, so we have another half an hour. So ask away.
I have a problem from WebAssign 1.2.
Okay. Okay, here's another question. This is from WebAssign. Section 1.2. Okay, so just be aware that the WebAssign will give different students different numbers. It'll change the problem. So for everyone watching this, you might not have exactly the same numbers, but the problem type should be very similar. So whatever strategy I do for this problem should apply to your problem as well. But yeah, what was the question number?
8A.
Okay, and what was the issue here?
So in parentheses, it's 8y to the 9th. No, the 9th is in the parenthesis.
Okay.
And then outside the parenthesis, it's to the negative 2/3.
Like that?
Yeah.
Okay. And
So I kept trying to solve it.
oh, what was the actual question? What did it ask you to do?
Oh, just to like factor and simplify.
Did it ask you to not use negative powers?
Yeah.
Or it says also only positive powers?
Yeah.
Which I'll make a quick comment on that since we're here. In algebra and pre-calculus, there are times when we'll make a big deal about, oh, you shouldn't have a negative power in your answer and you shouldn't have a radical in a denominator and things of that sort. One thing you should be aware of is that is something that we do in algebra and pre-calc just because we want you to get used to applying the rules that you are learning. So it just gives you extra practice in manipulating in items. But once you get to calculus 1 and beyond, no one cares if you have a negative power in your answer. No one cares if there's a radical in a denominator. So that's just a cultural tidbit right there. But yeah, so in this class and in algebra class, chances are people always force you to only write positive powers and never put a radical in denominator. You have to rationalize. Beyond this class, it's not a big deal, just so you know. It gives you extra practice with the manipulations, which is why we usually require it. Okay, so all right, what did you try here? Or where did you get stuck? Maybe tell me what you tried in the first few steps.
So first I distributed the negative 2/3 to both terms.
Okay, so you get 8 to the minus 2/3, and then what?
And then y to the negative 6th.
Right, because it's 9 times minus 2/3. And so you get 8 minus 2/3, y to the minus 6. Okay.
And then I tried adding those together.
Why? So that's a mistake right there.
Okay.
Why would you not add these together? Question to the class. So so what did you write? You wrote 8y to the minus 2/3 plus minus 6. Is that what you tried?
Yeah.
Okay, so this is the incorrect step. So why? So now that we know that it seems like someone is saying something in the chat. Different coefficient. What do you mean by coefficient? I think you're using the wrong word there. As what? Different bases is the problem. Okay. So why? It's because it's different bases. So remember what the rule is. The rule says, when are we allowed to add the powers? It's when you have x to the a times x to the b, you can get x to the a plus b. Notice that the bases are the same. You have a base x and a base x. Then we can add powers. In this situation, you don't have the same base. You have a base 8 and a base y. They're not the same, which means this rule does not apply. So this rule does not apply to 8 to the a, y to the b, right? It's not the same base, so you would not add the powers, okay? Now, when it comes to remembering the rules, which I expect you guys to remember, this is another issue. And again, this is a problem with students of various levels. The same kind of issue showed up in my calculus class again, where the fact that they didn't really pay attention to the specific rule and the nuances of the rule, they got in trouble. Things of this sort, when you memorize a rule, you really want to memorize it exactly. You want to memorize the entire equation. So there are a couple issues. Sometimes students will remember one side of a formula. They'd like remember the right side. They just remember, oh, I should add powers. Or sometimes they just don't pay attention to things like, oh, in this formula, the same letter showed up in these two positions. It means that for this rule, these two things must be the same, right? So if the bases could be different, the rule would not be written this way. It would have said an x to the a and a y to the b or something like that, right? The fact that they use x in both cases tells you that it must be the case that the bases must be the same in order for you to add powers. So that is the issue there. So the issue is memorizing a rule incorrectly, okay? So now that we know that we're not allowed to add the powers, what would you do? Anyone want to help her out? You can just chime in. You don't have to raise your hand. You don't know who that is.
Would
Carla?
you put them in the denominator so it'd be like 1 over 8 to the 2/3 y to the 6?
Yes, so that's allowed. And technically, that's because I'm technically skipping a step here. You can do each individually. So you can write as 1 over 8 to the 2/3 times 1 over y to the 6. But then the laws of fraction says I can just multiply across, so I can get that. Okay, we can still simplify a little bit. 8 to the 2/3 is something nice. How'd you figure out 8 to the 2/3? Like y to the 6, you can't really get nicer than that because you don't really know anything about y.
Is it the cube root of 8, so 2 squared?
Right, so for the 8, you can think of this as the cube root of 8 and then squared, right? And this is because of the thing that in class I called flower power. I want to kind of block this off.
I have a question about like.
Okay, so now 8, the cube root of 8 is 2. So the ultimate answer should be 4y to the 6. Okay, yes, the question?
Let's say in the future something didn't work out as nicely as like 8 to the 2/3 would. Do we still like want to break it down into that, like into a radical?
It depends on the problem. So if it didn't break down, like if it were not like something that the cube root of it was nice, chances are they don't like for you to have the radical in the denominator. So you'd probably multiply the top and bottom by something to make it an 8.
Okay.
So suppose we had something like, say, 9 to the 2/3, y to the 6, right? So this would be equal. This would be equal to 1 over the cube root of 9 squared y to the 6. But this is not a nice value. So instead, what you would do is you would do something like multiply and divide. So you would multiply and divide by something like the cube root of 9, cube root of 9. And then what you would have is you'd have the cube root of 9 over, now in the denominator, you'd have the cube root of 9 cubed. And so now this, the cube and the cube root cancel. And so you'd have something like the cube root of 9 over 9y to the 6. And that would probably be the acceptable answer if they didn't want the radical in the denominator. So here, this would be the acceptable answer if a rational denominator is required, meaning no radicals. Otherwise, you just leave it. Otherwise, just leave it as, you know, you just leave it in that form. But if you're in the situation where they say, oh, we don't want radicals in the denominator, then all you do is you rationalize. So yeah, so it'll look a little bit more complicated, but the idea would be either you leave it alone or you rationalize, depending on the problem. It's worth mentioning, though, that on, say, a multiple choice, what is important is that if I put the correct answer in either of these versions, if the answer response was the cube root of 9 over 9y to the 6 versus the answer response is 1 over 9 to the 2/3 y to the 6, you should recognize that these guys are the same and be able to pick the correct answer. But yeah, in terms of something where you have to come up with the answer and type it in without answer choices being given, it depends on what the problem requires. Hopefully that answered your question.
Yes, thank you.
Okay. Other questions?
Can you briefly go over the AC method again?
Okay, so AC method. Maybe I can use.
Or just yeah, just like a knowledge check on a specific question.
Let's redo one of these questions. So there was a question. Can you go over the AC method? Okay, so let me show you the steps. So given this, what you do is first find, so step 1 is find AC. Okay, now remember, we look at this as, think of this as ax squared plus bx plus c, right? So the a is always customarily what we call the leading coefficient, the b is the linear coefficient, and the c is the constant. So you actually find AC, which means you take the leading coefficient and you multiply it by the constant term. So that's the first thing. So AC in this case is 4. Then what you want to do is to find two numbers that multiply to give AC and sum to give B. Okay, so it's kind of like the old strategy where you thought of two numbers that when you multiply, you get the constant term, and when you add them, you get the middle term. You do that same thing, except now you think of the constant term as the AC. So in this situation, you would have, the numbers are
4 and 1.
right, 4 and 1. And the sign does actually matter here. So notice that it would be a +4 and a +1, since 4 times 1 equals 4, which is AC, and then 4 plus 1 equals 5, which is B. So once you find those two numbers, what you do is you rewrite the middle term using these two coefficients. Rewrite the middle term using the above two numbers as coefficients. So ultimately, you started with the problem 2x squared plus 5x plus 2. Your next step would be to write this as 2x squared, and you're going to write this as plus 4x plus 1x plus 2, where the 4 and the 1 the 4 and the 1 are from the previous lines. Sylvester got kicked out just now. Let me add him back. All right, you're back. Okay, so yeah, Yeah, so once you find, are you back? Are you hearing me, Sylvester?
Yeah, sorry about that.
Okay, yeah. So once you find those two numbers, so the first step is to find AC, multiply the leading coefficient by the constant term. Come up with two numbers that when you multiply them, you get AC. When you add them, you get the middle term. Then you're going to split the middle term into those two numbers. Then what you do is factor by grouping. So factor by grouping was the technique that what you do is you split it into two groups and you pull out the common term from each group. So if I look at, so x 2x squared plus 4x plus 1x plus 2, I would look at these two groups here as two separate things, and I'm going to factor out the GCF from both. So in the first two terms, 2x is a common term. If I factor that out, I would be left with x plus 2. In the second, nothing is a common term. I can pull out a 1. And what you should have here is what's left over in the parentheses should be the same. If it's not the same, you did something wrong.
Right. Okay.
So it means either the two numbers that you split actually didn't work. So for example, if someone thought the middle term split into 2 and 2, you'd realize you would not get these guys to match up, right? 4 and 1 were the things that you wanted to split.
Right.
What's left over in the parentheses should be the same.
So then it would be 2x plus 1 and then x plus 2.
Right.
Or you just leave it like, okay.
Right. Now this is a common term that you can factor out. So now, because x plus 2 is common, you can pull that out, and what you're left over with would be 2x plus 1, and that would be it. Okay, so let's do another quick run through, because here I was writing out the steps and it seemed like it took forever. So I just want you to see, like if you're doing something from start to finish, how it would actually look or feel or whatever. So let's redo this example. So here we're doing with AC method. So yeah, what I would do is I'd first find AC. This would be minus 12. I'm going to think of two numbers that when I multiply, I get minus 12. When I add them, I get 1. So plus 4 and minus 3 would work. So then what I'm going to do is I'm going to go back to the original. I'm going to rewrite the middle term as plus 4x minus 3x. And I'm going to factor by grouping. There's a common 2 in the first set of parentheses. There's a common 2x in the first set of parentheses. And there's a common negative sign in the second set of parentheses. Now 3x plus 2 is the common term. I can pull that out.
See, I like this. Well, would you say that you can answer every single question with the AC method, or would there be times where you?
Yeah, I mean, if the coefficient of the x squared is 1, then the AC method is overkill. But technically, you could still do it.
Okay.
So yeah, the AC method is a general method. It'll work no matter what.
Awesome. Thank you.
Yeah. But that's what it would look like. Other questions? And one thing I would say, it might come up, you should know how to check relatively quickly that your answers work. So you should know how to check your answer. Now, this is something that's very personal. So I don't remember if I mentioned this in class at some point, but I think at some point I will mention it. When it comes to doing well in this class or when you're learning anything complicated, you do have to remember that you are studying several things at once. First of all, there's the actual material that you want to learn. You need to pay attention to that material, know all the nuances, know all the strategies, etc. Another thing that's important to learn is how you react to the material, what mistakes you're likely to make, how your brain naturally works, and whether it's correct or not, how to correct for that, and etc. The third thing is relates to your instructor or your superior or whoever's giving you the problems to solve, right? So, and we talk about that. But when it comes to you, that's very important. So in practicing the homework, if you realize that every time you try to apply the AC method, you always make a sign error or something like that, then you personally, every time you factor, you need to check your answer, right? Not everyone would need to do this. If you're someone who you realize, yeah, once I get into the AC method, I always get the answer right. You probably don't have to waste your answer checking, but it's going to be a personal decision. It comes down to you, the topic that you're studying. Some topics you're going to find harder than others, and you want to be extra careful. But that's only something that you're going to learn about yourself by going through practice. So it's very important that not only are you paying attention to the actual thing you're studying, but you're paying attention to the kind of mistakes that you're likely to make. Are you always the person who's dropping a negative sign? Or are you always the person who's memorizing a rule slightly incorrectly for whatever reason? So like a common thing is for students to memorize the difference of cubes and sum of cubes rule with a 2 in the middle term. So that's something that's common. If you know that's you need to know that's you so that you don't make that mistake. Now, when it comes to knowing that you make a mistake, it's also important for you to know how to check your answer. So when it comes to factoring trinomials, here's how you can check your answer quickly, and you should just be aware that there's a way to check your answer quickly. So how it works is using a mnemonic called FOIL, which actually tells you how to actually expand parentheses, but I don't think it's good. So FOIL, remember, stands for first, outer, inner, last, right? So once you have an answer, so in this case, we had 3x plus 2 times 2x minus 1. So you should be able to check this, right? So 1, f means when you multiply the two first numbers. So this is 3x times 2x. This gives you 6x squared. So multiplying the first two numbers should give original leading term. If you multiply the last two numbers, so in this case, that's 2 and minus 1. You get minus 2. Multiplying the last two should give you the constant term, the original constant term, which in this case was minus 2. Now, when it comes to the O and the I, the sum of these should give you, the sum gives the middle term. So when you check your answer, what should happen is when you multiply these two, these are the inner terms. Here I would get a plus 4x. Then I multiply the outer two, which is the outer terms. Here I would get minus 3x. Now when I add these guys, I should get the middle term. So in this case, here multiplying the outer terms would give me a 3x times a minus 1. And I mean, what I'm writing down in green, you don't have to write. These are just quick checks that you can do in your head. And the inner terms, this is multiplying the 2 by the 2x. You would get 4x. And when you add these, the sum should give middle term. And so here you'll see that if I add the plus 4 and the minus 3x, I do get a plus x. Okay, so let's actually look at how to quickly identify that in another example. So there was another one that we factored. Let's actually check our answer. So we factored this guy into x minus 3 . So let's do an example. Check that this guy factors into x minus 3 and 5x plus 1. So if I have the x minus 3 and I have the 5x plus 1, now this is something that you can eyeball it, right? You don't have to like write down a whole treatise of why this is true, but you quickly check, do a mental check. If I multiply the two first numbers, I get 5x squared, good. If I multiply the two last numbers, I get minus 3, good. If I take the middle here, which is minus 15x, and I take the outers here, which is plus x, when I add these, the sum equals minus 14x. Good, right? So you can see right away, you can just look at it and see, oh yeah, I definitely did this right. Let's put that into a different color. Right, so you see how you can check your answers relatively quickly? So once you actually get to an answer, it should be good quickly for you to just go through and say, okay, yeah, I did that right. Right? So the red is the F, the FOIL. Multiply the two first terms should give you the original first term. Multiplying the two last terms should give you the original last term. To get the original middle term, that comes from the multiplication of the inner terms added to the multiplication of the outer terms. And that should give you the middle term. So you can mentally just do this quick check. After you factor, whether you use the AC method or the payback method or the trial and error method, whatever way you use, you can check it with this. That being said, to get the trial and error method to work, you would have already naturally do this check built in. So if you're doing the trial and error method, then you won't have to check, because like the checking is a part of the process in the trial and error method that I did in class. But if you did the AC method or the payback method, you may want to actually check your answer, and you can check it very quickly just by doing this mental check. Product of the first two should give me the original first term. Product of the last two should give me the original last term. If I take the product of the inner terms and add that to the product of the outer terms, I should get back the middle term. If any of these numbers don't match up, you made a mistake somewhere, or the thing doesn't factor. So yeah. Yeah, so I mean, we have a couple minutes. If there's another quick question, I'll take it. Otherwise, I think we can stop here. We had some good lessons learned from this session. So
I had a quick question about
yeah,
the quizzes. I'm not sure. Are we supposed to submit work with like scrap, like what we solve with the quiz, or is that something
no.
we're supposed to be doing?
So for
Okay.
quizzes, no. You'll be required to do that for tests.
Okay, got it. That's what it was. Okay, thank you.
Yeah. Okay. Let's do show work for quizzes. answer? Usually no. But yes for tests. So that being said, you should already start practicing saving your work for tests. So when it comes to actual tests, there are times when I'll ask you for a question to actually scan your work and upload it, or take a picture of your work and upload it. So you should know how to do this relatively quickly with your phone or whatever. So yeah.
I just have a question about where exactly we should be at for our homework, just because, I don't know, like there's not specific due dates, so I get kind of lost about like where we're supposed to be at and like what's, you know what I mean, like good timing, I guess. I just don't want to
Yeah.
get behind.
Let's see here.
I was trying to look for a guide, but the only thing that I found was on the syllabus. It goes like recommended questions in the text, but doesn't really say anything about what homeworks go with what dates or what lectures. So I think
Yeah, so you can track it by actually the topics that I write down on the board in class. So for example, if you look in the syllabus, which I'm doing right now, you'll realize that the quiz is covering up to sections 1.3. Right, so if you look in the topic section in the syllabus, you'll see that 1.1 is just the real numbers, 1.2 is exponentials and radicals, which we spoke about. 1.3 is algebraic expressions, which is just like the simplification and stuff that we were doing. 1.4 is rational expressions, which you'll notice that I didn't start that topic yet. So for now, I would say when it comes to homework, you should be at minimum up to 1.3. If you can get up to 1.5, it would be better. So
Okay.
chances are if I ask a bonus problem on the quiz, on the next quiz, it'll come from sections 1.4 and 1.5. But as far as what you need to know for the quiz, all homeworks up to 1.3 would be necessary.
Okay, thank you so much.
that makes sense. I didn't realize that the 1.1, 1.2 correlated with the homework. I just thought there were two different things.
Oh, yeah, yeah. So it's actually in the syllabus, the homework is labeled to match up with the syllabus. And then in class, I'd write the topics before I'm doing them. So you'll see at the beginning of lecture 8, I literally write down the heading rational functions or something like that.
Yeah, you do.
And then you'll say, oh, now he's on 1.4. So now you know that,
yeah,
okay,
right.
I should be getting, yeah. Okay, all right. So I think we'll stop there. Thank you for your participation. Thank you for your attention. Yeah, we'll stop there. Again, if you have any questions in the meantime, sure, you can shoot me an email. But for now, I will let you guys go. Okay. So, all right. Take care, everyone. Have a good week. Good luck studying, and I will see you in the next one. Ciao.